Have you ever looked up at a foggy sky and just thought, could you drink that? I know it sounds a little like science fiction, right? But what if I told you the solution to our massive water crisis isn't just buried deep underground, but it's floating all around us, totally hidden in plain sight? All right, let's get into it.
So that number you're looking at right now, that's how much fresh water scientists estimate is just hanging out in the Earth's atmosphere. To give you some perspective, that's about 10% of all the fresh water in every single lake on the planet combined. It's this enormous, untapped, invisible river flowing right over our heads.
And that really is the multi-billion-dollar question, isn't it? I mean, with billions of people around the world facing water shortages, figuring out how to efficiently grab that water from the air, well, that could change absolutely everything. The answer, as it turns out, involves looking at our own cleverness and, yeah, our biggest blind spots.
For a long time, the most common way to do this has been pretty simple. I mean, think about it. When you want to catch something that's in the air, what do you use? You use a net.
They're officially called large fog collectors, or LFCs. You can find them in these super foggy, mountainous places all over the globe, from the deserts of Chile to villages in Morocco and even Nepal. And they're basically just huge mesh screens that intercept fog. The tiny water droplets collect on the mesh and then just trickle down into a pipe. It's simple, it's pretty effective, and for a lot of communities, it's been a lifesaver. But there's a pretty big catch.
So let's look at the numbers, because they tell a really interesting story. On an average day, a standard fog net, that's the raw shell mesh you see there, it collects somewhere between, say, 1.5 to maybe 12 liters of water for every square meter. Okay, now even in perfect conditions, like they saw in Oman, you might get up to 30 liters. That's good, but it's not great. So why isn't it better?
This is why. That number, 2%, is the huge flaw in traditional fog nets. Research has shown that they only manage to capture about 2% of the water droplets that actually pass through them. The other 98%, it just blows right through. For decades, we've been trying to solve this huge problem with a tool that's just incredibly inefficient.
So, if our best engineering effort is only 2% effective, maybe we've been asking the wrong questions all along. You know, maybe the answer isn't to build bigger nets, but to find a better design. And for that, we have to look to the ultimate engineer, evolution itself. We're talking about the Namib Desert. It's one of the most arid, hostile environments you can possibly imagine. There are no giant nets there, and yet life finds a way. And one tiny creature in particular has absolutely mastered the art of pulling water right out of thin air, with an efficiency that just puts our technology to shame.
Meet the Namib Desert beetle. Every single morning, this little guy climbs to the top of a sand dune, points its backside into the moist breeze coming off the ocean, and it just waits. Little droplets of water start to form on its back, and then, almost like magic, they stream right down into its mouth. So how on earth does it do it?
The secret isn't about size or strength, it's all about elegance. The surface of this beetle shell is one of the most sophisticated water-collecting surfaces on the entire planet. It's a perfect combination of materials and tiny structures, all honed over millions of years to do one single job perfectly. It's this beautiful, simple three-step process. Okay, so its back is covered in these tiny little bumps that are hydrophilic. That just means they attract water. As the fog passes over, droplets stick to these bumps. As they get bigger, they merge together until they're heavy enough to roll down into these waxy, hydrophobic, or water-repelling channels. And those channels act like tiny gutters that guide the water straight to its mouth. It's literally an active water management system, all happening at a microscopic scale. And this little beetle's trick, it completely changed how scientists thought about collecting water from fog. It wasn't just a small discovery, it sparked a revolution in material science. The focus shifted from just catching water to actively controlling it. So this is the key insight right here. The problem was never the size of the net, it was the surface of the net. So researchers started to copy the beetle's back. They began creating surfaces with these alternating patterns of water-attracting and water-repelling spots. This whole field is called biomimicry, and honestly, the results have been nothing short of astonishing. And this table just brilliantly illustrates the incredible leap in performance. Look at this. We start with our old school mesh at about 12 liters. The very first designs inspired by nature, like those star-shaped patterns, immediately jumped that up to over 66. Then came advanced nanofibers, made from recycled stuff no less, hitting 134. And then came the real game changer.
865.1 liters per square meter per day.
Get this, that's the collection rate from a 3D fiber network that's decorated with these little nanocones, a design inspired not just by the beetle, but also by cacti and spider silk. That isn't just an improvement, it's a completely different league. We are talking about a potential 70-fold increase in water collection over the old nets. It's incredible.
When you put them side by side like this, the difference is just night and day. It's not even a contest. We went from a passive, super inefficient net to a high-efficiency surface that actively manages every single water droplet. We went from a simple material to an advanced nanostructure. One tiny detail from one tiny desert beetle has transformed a simple piece of mesh into a high-tech water generator.
Now, this breakthrough isn't just some cool science experiment. It really feels like the beginning of a whole new chapter in our search for sustainable water. Now, of course, the next big challenge is making these amazing surfaces cheap enough and strong enough to use all over the world. But the path forward is so clear now. Some of our best ideas are going to come from listening to the planet, not just trying to force our will on it. So what's the big takeaway here? Well, first, it's that nature is the greatest R&D lab on Earth, with billions of years of trial and error behind it. Biomimicry, it's more than just a cool buzzword. It's a really powerful way to solve some of our biggest global challenges. And maybe most importantly, it shows us that sometimes the most profound solutions can be inspired by the smallest, most overlooked creatures living right alongside us.
Which kind of leaves you with one last thought. What else is out there? What other brilliant, time-tested solutions are hiding in plain sight, just waiting for us to stop and pay attention? The answer, a lot like the water we're looking for, is probably all around us. We just have to learn how to see it.
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.